Let's talk about load balancer in this video. Load balancer is a hardware or software component which is designed to send incoming traffic to one or more of the backend servers. So basically it distributes incoming traffic to the backend servers. So that is all it does. Load balancer is one of the key enabler for horizontal scaling. And with horizontal scaling, we get higher throughput, lower response time, and we also increase the availability of the system. Load balancer generally uses some sort of algorithm to decide how to send the incoming traffic to the backend. So those algorithms can be either static or dynamic. If it is a static algorithm, for example round robin algorithm, load balancer will not know the current status of the backend server. It will simply make the decision based on its static algorithm. So whenever the incoming traffic comes, it will run the algorithm, it will decide which backend server it should go to, then it will send the traffic. For example, if we are using round robin algorithm to send traffic to the backend, then the load balancer will send the incoming traffic to one backend server at a time in a circular fashion. So it sends to the first server first, then the second server, then the third server, and it comes back to the first server again. So it will simply forward traffics in this circular fashion to all the backend servers. So that is what a round robin algorithm is, and this is a static algorithm because it doesn't take any of the current status of the servers into account. On the other side, if you are using dynamic algorithm, for example, then the load balancer will know more about the backend server and their current load as well. So if you are taking least connection as one of the example of dynamic algorithm, then the load balancer will look at the current load of each of the server by looking at the number of active connections they have, and the incoming traffic will be sent to the server with the least number of connection. So this way, the decision of sending the traffic to the backend server is decided purely on the current status of the backend servers. So this type of algorithm is called dynamic algorithm. And the load balancer can also be either stateful or stateless. If it is stateful, then the load balancer will maintain some sort of session for each of the incoming connection, and it will use that session information to decide where to send the traffic to. So this will be useful for things like session affinity, where you want to send all the incoming connections from a particular client to the same backend server. So this can be achieved if the load balancer is stateful. On the other hand, we have stateless load balancer. The stateless load balancer will not maintain any session information about any of the incoming connection. In general, stateless load balancers will be faster than stateful load balancer because it doesn't need to maintain state information and it doesn't need to do any lookup. So this way, stateless load balancers are much faster compared to stateful ones. And one final thing that I wanted to cover about load balancer is that load balancer can operate at layer 4 or at layer 7. Layer 4 is network layer, and in this layer we operate using TCP or UDP protocol. So the load balancer will be able to look at these TCP or UDP packets to make the decision of where to send the traffic to. On the other hand, if you are using layer 7 load balancer, layer 7 is application layer, and in application layer we'll use protocols like HTTP and other application level protocols, which means the load balancer will be able to see much more contextual information. For example, if you're talking about a web traffic, then the load balancer will be able to see the HTTP header, URL and all those information, and based on that it will be able to decide where to send that traffic to. For example, if you have configured your load balancer to send requests to a particular URL to always go to one particular web server, then the load balancer will be able to see the URL and send the traffic to the right backend server. So this way, operating at layer 7 is going to give us much more control and contextual information, but operating at layer 7 is going to be slower compared to layer 4 because we are working at HTTP level. On the other hand, with the layer 4, we are working at the lower level protocols like TCP or UDP. So the decision to where to put your load balancer purely depends on your use case. So that is all I wanted to cover about load balancer. I hope this is useful. Thank you.